Hey everybody, so today we're going to go over Chapter 5, which is all about trigonometric functions. So I'm going to start by explaining 5.1 and 5.2. 5.1 is modeling periodic behavior. A cycle is one complete repetition of a pattern. So here we see, let's say this point right here, it goes up and it comes back down. And then it repeats the same pattern over and over again. So this right here is one cycle. In part B, let's just pick a point and then see where that point reoccurs. So that's about here. Now we also have to make sure that it follows the same path. And if we look at it, it does. So therefore, this right here is one cycle. Now a period is the horizontal length of one cycle on a graph. So we just learned what a cycle is. Now if this is a cycle right here, the period is simply the horizontal length of that one cycle. And if we look, that's approximately 6. So therefore the period of this function is 6. Now a periodic function is a function that has a pattern of y values repeating at regular intervals. So the first one is periodic because it starts at 0, goes at 1, and then goes back to 0, and then 1, and then 0, and then 1, and so on. But the second one is non-periodic, even though it looks as though it's repeating and it's like a pattern, but it's an upward trend, and therefore it does not have the same y values. And we know that a periodic function is a function that has a pattern of y values repeating. So therefore, the second one is non-periodic. Now the amplitude is half the distance between the maximum and minimum values of a periodic function. And from that we can form an equation. Amplitude equals max minus min divided by 2. So here we see that the max is 10 and the min is negative 10. So simply plug that into the formula. Max, which is 10, minus, in brackets, negative 10 divided by 2. And that gives you 10, which is the distance from here to here. Therefore, the amplitude of this function is 10. So some of the questions that you may come across: periodic or non-periodic. So you'll be given a graph and you'll have to state whether it's periodic or non-periodic, and most probably justifying your answer. So in this case, you can just pick two points and then follow its path to see if it's periodic or not. And here we can clearly see that it is periodic. And so you can end by simply putting a sentence as the following. The above graph is periodic because the pattern of y values repeats on a regular basis. Another type of question might be a graph analysis, where they'll give you a graph and ask you questions about the graph. So first of all, how many cycles are shown? Well, you see one right here, and the same occurs on the other side. So therefore, 2 cycles are shown. What are the maximum and min values? Well, the maximum right here is 1. So therefore, max equals 1. And the minimum is negative 1 right here. So that is minimum equals negative 1. Another type of question they might ask you is, what is the amplitude? And you know that amplitude is max minus min divided by 2. So your max here is 1, and your min here is negative 1. So once again, 1 minus bracket negative 1 divided by 2. And that gives you 1. So therefore, amplitude is equal to 1. And what is the period? Well, you can clearly see that the period is 2 pi, which according to our chart is 360 degrees. Now this is one of the questions on our quiz. So I'm not going to read this due to the lack of time. I'm going to go straight to the answer. So first of all, you're going to state your givens. You've been told that the period is 8 and you've been given 3 values. So the idea here is to take that required value, subtract an X amount of periods to get any of the given values. So for example, f of 9 is 9, which is a required value. Subtract an X amount of periods, which in this case is just 1, to give you a value of 1, which is one of the given values, f of 1, which is negative 3. So if you know f of 1 is negative 3, f of 9 will also be negative 3. And that's the same for B and C. For For d, however, f of 29, a prediction for this value is not possible, as no x amount of periods subtracted from 29 equal any of the given values. So moving on to 5.2, the sine and cosine functions. Here's a chart of the properties of the sine and cosine functions. The darker shaded boxes show the differences between the sine and cosine functions, and the lighter shaded boxes show the similarities. The same chart can be found in your textbook in page 298 under key concepts. So some of the questions that they might ask you is sketching graphs, so you may have to sketch a graph. And for this, you'll need to know the basic points of a sine and a cosine graph. They might also ask you application questions, such as one in your textbook, which is all about the horizontal and vertical displacements. So once again, for the lack of time, I'm not going to read this. I'm just going to go straight to the answer and solve it. So the first thing you're going to do is create a diagram and then create your axes. So right here. And they told you that you're supposed to begin at your standard position. Normally you'd begin at the bottom, but for this case you're going to begin along the positive x-axis. So now they're asking us to create a graph. The horizontal displacement is whether it has moved left or right from the center. So in this case, at 0 degrees right here, from the center, it has moved 8 meters to the right, since they told us 8 is the radius. Now at 90 degrees, if this were to go up, it would be right over here. And that right there has not moved neither left or right from the center. So therefore that would be at 0. So your first point would be at 8 and your second point would be at 0 in 90 degrees. Now at 180 degrees, you are right over here. And that is negative 8 meters, because you're along the negative x-axis. So that would give you a negative value right here at 180 degrees. Now if you're to go to 270 degrees, that's once again back here, just like 90 degrees, where you're at the center and have not moved neither left nor right. So you'll be back at this point right here. Now, to return back, and that is 360 degrees, that's the same as your standard position. So whatever your standard position was, would be your ending value, which is right here at 360 degrees. So now if you look at this, this resembles a cosine graph. So this would be a cosine graph. Now they've also asked you a vertical displacement. So let's start once again by drawing our axes. And once again, to start at the standard position at 0 degrees. Now they told us the vertical displacement. That's what they're asking. And vertical displacement is whether it's gone up or down. So at this point, at the starting position, we've neither gone up nor down. So it's at 0. So the point right there would be right here at 0 degrees. Now if we were to go at 90 degrees, right over here, this has gone 8 meters up from our starting position right here. 8 meters up. So therefore you'll have a positive 8 value at 90 degrees. Then if you're to go to 180 degrees, which is over here, you have gone back to 0 because you've neither moved up or down from your starting position. Okay. And if you were to continue and go to 270 degrees, you will be back at this point. However, it's not 8 meters, it's negative 8 because it's below your standard position. So that gives you a negative value right over here. And then back to your starting point. So it would be the same place where you started off as your starting position. So now if we look at this graph, this resembles our sine graph. Therefore, this is the vertical displacement would be modeled by a sine function. So that's all for 5.1 and 5.2. Thanks for watching.